Uh, Today is our third day of the FDP program, Industry 4.0 Technological Revolution. Uh, Today, our speaker is Dr. Sumit Bhumik, sir, from NIT Silchar. He has already joined the session. So, before starting the lecture, I want to give a short introduction of Bhumik, sir. So, Dr. Sumit Bhumik received his BE degree in Mechanical Engineering from Tripura Engineering College, now known as NIT Agartala, under Tripura University. MME degree in Machine Design Specialization from Jadavpur University. He has done in his PhD from Jadavpur University. He joined as an assistant professor in the Department of Mechanical Engineering in NIT Silchar in January 2013. He also worked as a faculty in Tripura Engineering College and Asansol Engineering College. He published more than 60 number of SCI journal papers in different reputed journals and was the author of 3 number of textbooks. He also published number of conference papers and book chapters. 8 number of research scholars and 19 number of PG students successfully completed their research work under his supervision, and 2 number of research scholars working under supervision now. His work is also funded by the CPRI, KVIC, and NSA. So this is a brief introduction of our today's eminent speaker. So, Bhumik sir, over to you, sir.
Okay. Good afternoon, everyone. Thank you, Dr. Rajdeep. It's
Thank you.
nice to see you after a long time. Okay.
Yes, sir.
So,
Yes, sir.
may I share the screen?
Yes, sir. Yes, sir. Sure.
Okay. Is it visible?
Yes, sir. It is visible, sir.
Okay, since the top FDP is relevant to the industry 4.0, so here I am presenting, giving you some overview the work we have carried out relevant to the industry 4.0 or the product development and its problem and other related. So the and that way the title has been made for the development and utilization of natural resources for composite material for application in the industry. So as all of you,
Sir, Bhumik sir,
uh,
sir, slide is
yes,
not showing.
not showing.
Uh,
Uh, but I shared the full screen. Okay, just give me 2 minutes. I will log in with other ID. Okay.
okay, sir. Okay, sir. Okay. So, dear participants, wait for 2 minutes. As our eminent speaker is will log in again, and will reconnect within 2 minutes.
Is it now visible?
Sir, a white screen is visible only.
Yes, sir, visible.
Visible, na? PPT now?
PPT is not shown, sir.
What is the problem? I'm not able to. Now?
No, sir. Yes, sir. Now it is showing.
Okay. So these are the some title or table of content. Now here you can see the background and motivation. Now look, since the technology developed day by day, so accordingly we have to think about the different kind of material and product which need to be helpful to the society, and accordingly we think about that as everywhere environmental consciousness is more important. So if you can see this slide, there are how many wastage are coming every day through the plastics and other resources which need to be replaces. And if you see in that way, if it is going on, then up to 2050, that it will exceed the number of fishes from the sea. So we think that so that is any material which can be developed for replacing the plastic. On this motivation we started working that which will be helpful for the environment as well as balance the price performance ratio of the component. So in that case a sustainable material which we need to be considered from the agricultural resources. Now in that case most important part is that the composite material which can be used as a replacement of the plastic, though plastic is also a part of the composite material, but if we can classify that plastic in a composite material or reinforcement material. From this slide you can understand that traditional natural fiber, industrial co-product, agro and forestry residues, recycled fibers and polymers are to be considered as a sustainable reinforcement or filler materials. And it has to be reinforced or filler in a polymer matrix, which are also based on different categories, that petro-based non-biodegradable, bio-based biodegradable, as well as petro-based biodegradable and bio-based non-biodegradable. So it is better that if we select both polymer matrix as well as reinforcement material for any product development, then it will be little bit helpful to the environment as well as sustainability of the product. With respect to that, there are different application need to be. First of all, then since we are replacing, that first question comes. So most of us we are using the what called the plastic in a water bottle. So is it possible to replace that water bottle with the composite material? Yes, there is a possibility, but till the since water is drinking water and it will be directly going to the human body, so there are some issues comes with the biological matters which need to be considered and it need to be addressed properly. But if even that plastic bottle are not to be replaced, but some products where everyday life we are using which are not directly involved in the human body reaction, we can consider for the um, polymer biodegradable polymer material. Now why this composite we have selected, not the direct fiber or polymer? Because if you consider any kind of natural resources which has comparatively less strength or the other property compared to the metal or the synthetic fiber we are using, so it is better to replace the material, synthetic material or the plastic with the help of the uh, composite material. So that the main benefits will come: strength and durability compared to the natural resources material. Like, if even if we consider the jute fiber, I think jute, all of you are aware that the bag and other material we are using for the jute fiber. But if we incorporate jute in addition with the composite material, it will give more strength and durability. Also, it will be lightweight compared to the traditional material, and it can be customized specifically, since we are targeting to develop a material which can be used for different product. So only one material, one dimension is not only the criteria, but it has to be customized for the different application. So why natural fiber based composite? Because of course, as I mentioned, it is sustainable. At the tons, there are a lot of natural resource are available which are environment friendly. You no need to synthesize or something else which artificially created. Then natural lightning, it is, of course, if you see that any fiber or the filler you are considering from the nature, it will give less weight in nature, eco-friendly. It can be applied depending on your requirement, any kind of application, and as well as, of course, the environmental impact. Okay. So in generally, that classification, though we have mentioned in the earlier slide that biodegradable reinforcement, sustainable reinforcement or fiber, in that fiber also there are different classifications are there which we need to be considered before selecting the fiber or development of the product. One is plant based resources, another is the animal based resources, and another is biopolymers. So there are three category wise considered that whatever the natural product we are getting, one is from the animal, one is from the petroleum based bioproduct or some other material we are getting bioproduct, and another is plant based resources. So we mainly focuses on the plant based biofiber products. Okay, since we are I'm working in the northeast domain, so the plant, there are several variety of plants are available, and it's different, easily available in different seasonal uh, plants are available. So that's why we mainly concentrated on the plant based biofibers product. So in plant based biofibers also, it has to be classified in different category. One is stem, like wood and bamboo we are considering. Another is leaf, that sisal, pineapple, agave. Then bust and skin, fruits, seed, stalk. These are the different categories we are. Not only this category, there are also some other, some cases roots also considered for the specific application, or root based fruits or the vegetables also can be considered for plant based biofiber products or origin. So if you see that biofiber from the, now that plant based biofiber what we are getting also directly from the plants, directly from the other resources and other product. So in the first figure, if you see that some are comes as a fruits and vegetable, some are comes as a skin and all that product. Even after eating the fruits, we'll throw the some skin and the seeds and some stems for the waste as a wastage. And that also, or directly we can use that leaf or the stem or the straws from the product. Okay, so that has to be considered for the plant based biofiller or fiber from the fruits and vegetables. Similarly, that some food waste for bioplastic production can also be used. That some food products, like if you simple one example, that we are using eating coconuts and bananas, So most of the case the banana peel will throw out, then the outer surface of the coconut we throw out, and we are not using for any product. Sometimes we are using for the puja or devotal purpose, but that also can be used for the product development and structural component. Okay, so these are the some images from where we can use natural plant, that we are mainly use in our product development and consideration. So specifically we selected some specific um, fibers from the natural plant because of its lightweight and due to low density, high specific strength and modulus from the technical part, and good environmental credential like renewable, biodegradability, and easily available, also non-toxic to the uh, human body as well as um, other component, then easy to waste and balance the carbon emission of the end of the life cycle. So in that case we are considering mainly banana, bamboo, hemp, jute, nape, palm, pineapple and sisal. So these are the some product considering this criteria, the right side criteria we have selected for the product development, and it also easily available uh, in the northeast India of the part. Now, whenever we go for the replacement of some product or some item, and we need to know the structure. Though I have mentioned that we have it is a less carbon emission, easily available, non-toxic to the environment. But the thing is that when you are selecting that fibers or polymer, are they able to make the composite with the polymer matrix or the other matrix material? What is their chemical composition, what is their chemical structure, that also need to be considered. Else suppose I collected some fibers or filler from the plant or agricultural waste and immediately mix with the polymer matrix, so it will create some hazardous reaction which need to be addressed or which are not desirable during the product development or component development. Am I audible, na?
Yes, sir, audible.
Okay, if not audible, please inform me. Okay,
No, no,
so
sir, it's
for
audible.
that chemical composition of the filler or fiber, since I have mentioned that we are considering banana, pineapple, this, what is their common, almost similar kind of chemical composition inside chemical composition we have considered? Like if the plant cell consider, then it will contain the cellulose, hemicellulose, lignin. That is the how the structure of the lignin is there, then how the hemicellulose, microfibril, and the hemicellulose or lignin are situated. Now if you see in the first figure that the lignous cellulose is given a structure. Now if this structure, random structure or random size of the randomly moving the lignin, then it is very difficult to make the bonding with the polymer matrix. So since these plants whatever we have selected as a uniform distribution of the lignin, so that they can easily react or make a bonding with the lignose and the polymer matrix of the component. Okay, so these are the basic things we have considered when selecting the fibers from the natural resources. Now these are fibers we have selected, or the filler selected natural resources is mainly the plant based. Now there are some other natural resources as there, as I have mentioned, that animal based or bio product, which byproduct which are we are getting from the petrochemicals products or some other resources which we have not specifically considered. This is mainly for only we have considered from the plant based byproduct. Now since uh, polymer matrix also need to be considered for preparation of the composite material. So in that case there are two types of polymer matrix we are consider for development of this kind of composite. One is thermoplastic and another is thermosetting polymers. So thermoplastic mainly are the polyethylene, then polystyrene, PVC, PVA. These are the thermoplastic. Plastic means when you make a composite material for using the thermoplastic polymer, it becomes softened. It can be reshaped or reused after even making the composite after the life cycle of the product. Then you can separate the polymer matrix from the product and you can reuse it. But in the main problem is in thermosetting plastic thermoplastic polymer is that they are not able to take the load as much as can be taken by the thermosetting polymers. So in that case also thermoplastic polymers become softened very easily and reduce temperature. When we need to work for a high temperature product, in that case thermoplastic polymers are very difficult to work. So on the other side, thermoset polymers are not easily reshaped, softened and reshaped again and again is not possible. So some of the example is phenyl formaldehyde, nylon, urea formaldehyde, epoxy resin, etc. And also, so dealing with the thermoplastic polymers is little bit difficult because it required proper melting temperature, proper handling, and proper preparation of the composite. So, as already I have mentioned, these are the highly we preferred thermoset polymer, though it has less important. It can carry the high heat, high pressure, and light radiation, and high flexibility also possible with great strength and modulus. Whereas thermoplastic has consist one or two dimensional molecular structure in compared to the thermosetting polymer. So we can easily bond with any kind of polymer. As we have mentioned that in plant fiber we got cellulose, lignin, hemicellulose. So these also need to be properly bond with the polymer matrix. Since the thermosetting polymers have a cross-link structure, so it can easily be bond with the plant-based polymer. Polymers, we consider the epoxy resin material. So in epoxy resin also there are two category comes. One is biodegradable, another is non-biodegradable material. So some work we have carried out considering the biodegradable polymer matrix. We have some work carried out with the help of the non-biodegradable polymer or product. So both the cases, if you consider biodegradable epoxy resin or non-biodegradable, both of them are easily available. It can be very less cheaper in cost, and also it has a good mechanical and fatigue strength, viscous property, moisture resistance, chemical resistance, and electrical property we can get from this component. Now, after studying all these things, suppose I selected specific material, bio plant-based product, selection fiber or filler we have considered. Another we have considered bio epoxy polymer. Now how they has to be prepared or reinforced in the polymer matrix so that proper uh, composite can be prepared. So in that case, there are two provision. One is you select the fiber, make the mix with the polymer matrix and prepare the composite. Another thing is that you collect the fiber, make the filler, and mix with the polymer matrix in develop the composite. So we mainly concentrated on the filler based product because why not fiber based? In fiber the main issues we got is delamination, so that its delamination comes because of their proper dimension, maintaining the proper length, diameter of the fibers, and then chemical treatment of the fibers, then the homogeneity or isotropic property of the composite material, uniform distribution of the fiber. That becomes for little bit difficult and prepare. I am not saying it is not possible. There are a lot of work going on the fiber based product, but since these are the problems already known to us, that delimitation, orientation, homogeneity, isotropic is not. So let's try on the filler based composite. So in that case, whatever the fiber or the filler shape we collected, first of all, that has to be grinded, and then it has to be placed in the ball mill so that fine micron level filler can be developed, and that has to be categorically classified in different group. For example, smallest filler we have considered that 125 micron, then it will be go to the 255 micron, then 500, then 1 millimeter, then 10 millimeter. But when it is exceed the micron level, we may also this can be considered as a short fiber of the component. So these are the some schematic representation of the different filler prepared from the different resources like bamboo, banana, coir, ham, jute, pineapple, rice, and wood powder. Okay, so after that, since filler has been prepared, so it include some uh, chemical treatment, and that has to be mixed with the polymer matrix with the fiber, and then extrusion and pre-processing to be done, and then the final product we have to carry it out. So these are the some schematic representation of the final product which we have targeted for develop the replace the synthetic fiber based composite or the metal based material with the help of the polymer based composite with the natural resources. Now to how to prepare the sample, but for this purpose we want to include one thing. Whenever we develop the composite, one more thing is important, is that I am mixing with the banana fiber or filler with the epoxy resin and telling that it can be used in the uh, bullet, to make the bullet, or in a tank. People will doubt me that is whether it has the that much of strength or that much of frictional behavior property, heat transfer rate, machining property. So lot of studies need to be carried out with respect to that material. So most of the cases, first what we, after preparation of the filler, this has to be mixed with the bioepoxy resin with certain percentage with hardener. Then they has to be mixed in the sonication with specific RPM, because this has to be done to make the, as I mentioned that in the fiber based composite material, the main issues comes with the orientation and delimitation, so homogeneity and isotropic. So if epoxy has to be properly distributed and the filler need to be properly distributed, then sonication with specific RPM we have to carry it out. Then due to the rotation, some void has been generated in the composite which need to be removed. For that, vacuum desiccator or vacuum chamber where we have to bring out all the void inside the sample, and then as per requirement of the sample we have to testing requirement, we have to make the molds, and that has to be prepared the sample. Now in this case, one more thing I have to mention, that to making the sample or the product, there are in between some work need to be carried out, that whenever the filler has been prepared, it need to be go through the some chemical treatment, because most of the cases we have collected the raw fiber or filler from the open environment, so it contain large number of moisture content, foreign dust particle, and some other foreign particles which need to be cleaned up for making the proper bonding between the resin and the hardener of the component. So in that case, the chemical treatment before mixing with the hardener or bioepoxy resin, uh, the chemical treatment to be carried out. Now, what are the test or characterization of the composite need to be carried out, which was developed from the natural resource based composite. So there are some physical properties, some mechanical, some tribological, then dynamic property, then the thermal behavior, and the microstructural studies which need to be carried out in between them. So here some of these experimentation depending on the application and other behavior we mainly carried out. For example, that physical property, most all the testing or the experimentation need to be carried out. Then mechanical property, in between that we have not investigated the compressive shear impact or the fatigue, and some cases fatigue fracture also we have done, but not for all the cases. But in case of tribology, because friction is most important, that in my next discussion I will go through that what are the, then the DMA analysis, most of the cases we have carried out. Then TGA analysis as much as possible, thermal conductivity and weight loss we have carried out, and thus microstructural study we have investigation. Now if you see, as I mentioned that uh, before mixing with the epoxy resin with the filler, some chemical treatment, that NaCl solution to be made and pH 7 level has to be achieved, so that the foreign particle and foreign dust or the moisture which are available, which need to be removed. So in that case, some treatment has to be carried out. Now the question is, if we do the treatment, whether the treatment is done properly, whether is it there are some improvement in the crystalline index or crystalline plane is there or not, whether the amorphous area increased or crystalline pore structure is to be increased or not, that has to be considered. So if the intensity is more, that means the crystalline index or crystalline plane is not properly, it has less provision to make the bonding with the material. But if it is less, then we have to consider, increase, then we have to consider. So from here, if you see the representation, that XRD analysis has been carried out both the treated and untreated fillers. So crystallinity and the intensity of crystal plane has been increases for the treated filler compared to the untreated component. Also the amorphous area and other crystal pore structure also increases in compared to the uh, treated untreated filler. Means the treatment we have carried out, that also prove that whatever the foreign particle, whatever the component has been foreign dust or the any component available, that has properly be removed and it has been improved for making the bonding. So same way the Fourier transformation analysis has been carried out for both treated and untreated mm, uh, filler, so that hydroxyl group can be in changes, so stresses or more, so that the proper um, bonding and with the epoxy matrix to be carried out. But these are specifically for the biofiller we have considered. Okay. So same way the EDAX analysis of the component has been carried out to show the peak of the composition, whether the carbon component or oxygen component is there, how they will react, or the different decrease the moisture contents or reducing the carbon or oxygen composition, so that it can be properly bond with the epoxy matrix or resin. Now from here, if you see that microstructural analysis of the biofiller, now if you see in the unrated filler, there are so many fibers, so which need to be removed, so that proper bonding and so proper property can be found out. So on the other side, if you see that treated filler, that 90% of the uh, foreign particles or the broken particle bond grain is removed from the fiber of the or filler of the composite, so that it can make a proper bonding. In simple language, and for stitching purpose, in needles we have to insert the uh, different types of tie, so that in that case we use the mouth, so make the beginning of the tied shape properly shaped, so that it can be properly inserted in the backside of the needle. So same thing concept is there, because that was done. We cannot do the chemical treatment for every cases, and simple to make the fibers orientation properly. Now to next comes to the other physical property. The most important part is that the porosity or void content. Though the vacuum desiccator has been used to remove the void, but it is very difficult to say any product which we have considered that 100% void free. Okay, so for that, what content testing has to be carried out, and density, whether the uniformly densed or not uniformly distributed, that has to be carried out. So one is experimental density based on the Archimedes principle, and then you have to absorb the water and find the density of the water and find the weight difference of the component, so that you can find the volume and the density. Same way void content also need to be carried out, but it is to be mentioned in between that every test to be carried out accordingly STM standard. So if you see here, some STM standard has been mentioned, which we need to be carried out in different conditions, so that density and void content and water absorption capacity to be conducted. So another next comes to the after physical characterization or physical property investigation. Next we come to the measurement of mechanical property. In most of the cases in our material, we have conducted the tensile and the flexural stress. Flexural testing means the bending stress development on a pure shear condition, or pure bonding moment condition. So, and this has been done in a servo hydraulic universal testing machine, which has a capacity of 100 kilonewton, and the different experimental setup which we have done, and the prepared sample which has been carried out has been mentioned here. Okay. So also the tribological behavior has been carried out for in multi-tribonivator, which is to be pinion disc, and it also to be carried out uh, at different ASTM standard. And most of the cases we have considered the uh, cylindrical sample for making the, and when we make the product or bring out the uh, sample from the mold, there is some different variation in the dimension, so that has to be polished properly in a dual disc polishing machine, so that surface has to be smooth and proper properties to be measured. And this is the schematic representation of the same analysis or same structure which is been considered. Since in most of the cases it has been observed that the composite thermosetting polymer composite developed here is non-conductive to the electrical property, non-conductive to the magnetic property. So sometimes it is very difficult to measure in scale even fractured surface without the some coating. So there are some gold coating has to be done, and then the same analysis to be carried out. Okay. So next the some result has been represented for different material. If you see that most of the cases, now to prepare the sample, what we have done, and the filler content, first of all we make that filler content at a 0%, that only the what is the epoxy percentage. Then also the sample has been prepared increasing the filler percentage in the epoxy resin, like 2.55, 7.5, 10 and 12.5 percentage filler content. So it has been observed that most of the cases different property, whether it is a physical, mechanical. So filler variation is with the increase of filler content up to 7.5, 2.5 in some property, in some cases 5% filler content, or in some cases 7.5%, the best property has been found, whether it is a tensile, flexural, modulus, or tribological, or some other cases. But after that 10.10%, it is decreasing again, start decreasing the property of the material. For example, if you consider the filler of here, you will find that 5% filler content has been going, giving the best tensile property. Okay, so these are mainly representation of the untreated and treated jute filler composite. Okay. Both tensile and modulus and as well as bamboo filler has been given. So in jute, if you see that 5% filler content will give the best tensile property, whereas the um, bamboo is given 7.5 at the different. Also, all the tensile test or the flexural test carried out at different speed or different strain rate, because when I pull or push the some object with some velocity has been given to the component. So to address that issue, different strain rate has been considered, that 1% 1 millimeter per minute, 2 millimeter per minute, and 3 millimeter per minute has been considered. So most of the cases it has been observed that 1 millimeter, as the speed is increasing, of course the strength will decrease of a composite material. Now the question is, why after 10% or 12% filler is decreasing, though it should increase the property? But it has been observed that from the microstructural analysis and other analysis, that after 10 per 7.5% the agglomeration occurs, because they are not going bond with the properly, since the density of the filler content is increasing. There are some space generated where the epoxy is not able to enter in between the two filler component of the uh, composite, and they are not able to proper bonding. So when the load is applied, since they don't have any bonding with the epoxy or resin, and no correlation with them, immediately that has been broken. So similarly, the flexural stress or bending stress has been evaluated, because to apply the load, in that case also, in case of jute filler, it has been observed that the flexural strength is found at the 5%, whereas in case of bamboo filler, the modulus of rupture or the flexural strength has been found in 2.5 as well as 10 percentage of filler. Now, next come the tribological behavior of the polymer composite. Now, why tribological behavior? Because in most of the cases or any product, it always face some frictional uh, load for any application, whether you are using a mobile or you are using a glass for drinking water, bottle for drinking water. Everywhere the friction is there. Without friction, even we cannot stand on the earth. So for any product development, any composite development, frictional investigation of the frictional behavior is one of the important criteria. So from here, you can say that most of the mm, world energy is originated from the tribological concept contact. So also that will lose the vehicles, machinery, and other equipment reduced by 40% of its lifetime and due to the frictional behavior. Now, if we consider the friction and wear, so people are make some confusion with that. So here, if you can see that friction, how the friction and motion and pushing force are there, which need to be considered. Also, the wear is damage the behavior. Most of the cases, if you best example for the wear behavior is bicycle brake. If you ride the bicycle in very high speed, if you see and pull the apply the brake suddenly, you will find that after 2 weeks or 3 weeks you need to replace the rubber of the brake, because that is due to the friction that wear occurs and the material is removed from the uh, component. So there are three types of wear, stage of wear occurs. One is primary stage or early running period, then is secondary, and the third is tertiary or the old age period, and after long period of time, and the material has been uh, need to be replaced. So there are several types of where occurs that adhesive, abrasive, surface fatigue, corrosive, erosive, and fretting of the wear. And each of them has been represented in an example. So I'm not going in a theoretical class what is the abrasive wear or what is the adhesive. These are the some wear occurs which we need to be addressed. So most of the cases we have to consider the abrasive wear of the or adhesive wear of the component. So when we want to investigate the wear property or wear behavior of the component, some uh, input parameter we have to consider. Similarly, we have to get some output parameter. So for input parameters, for example, since we are conducting the tribological behavior or we are investigating the wear behavior in the multi-tribometer machine with an STM standard and the cylindrical sample has been considered. So there also some variation occurs. So whether the tribal measured the where behavior on a specific load, normal load you have applied, or you have varying the load. Whether the velocity you have given, speed we are moving or rotating, that in a one specific category or the different sliding velocity has been considered. Also for the distance we are considering. So if you sliding distance, if you travel 100 meter, then some friction will be occur. If you travel 200 2000 meter, then different sliding distance as well. Also there is a some temperature difference, whether high heated condition we are doing or in a room temperature condition we are doing, that has to be considered. Also the counterface material and the uh, sliding distance or the sliding velocity of is considered, whether in a lubricating condition or a dry condition or a wet condition we are considering, that has to be considered as an import parameter. And from there what we will get, that the volume loss due to that friction, how much material has been lost its volume, then how much wear rate has been considered, friction coefficient, and the roughness of the surface occurs. Okay, and of course that after that microstructural analysis has to be considered. Now here some jute filler has considered most of the cases. Why, if you think that why we are not consider wood, banana, or some other, that also done, but here I am representing most of the cases jute and bamboo. Compared to other filler, this has good properties compared to banana or pineapple or other component of the material. Now here if you see, when the load is varying, in that case in a wear rate with the increased load is increasing, but the best property has been found at the 2.5% of the filler for a jute composite. And if even if we increase the temperature also with the load, the temperature, if the load is increasing, temperature also increasing, coefficient of friction also increases. Similarly, with the sliding distance, if we the thing consider if the distance travel by the component developed, so with the distance the wear is more,
temperature is high and the coefficient friction is high. But it has been found that 2.5, 7.5 are most of the cases giving the minimum disk temperature of and coefficient of friction with the 1000 to 1000 sliding distance. Okay. So since this decision to be come out with a study as a output parameter, not only from the result but the microstructural analysis also we have to consider. So this is the microstructural analysis of different pillar debris and different torn surfaces of the component. So these are the some coefficient versus result with the sliding distance and of different loading condition. If the load also increase, that coefficient of friction varies, increases with the sliding distance, and then load at different loading condition. So in generally what we have considered that with the variation of pillar content, the load has been varies from 5 Newton, 10 Newton, 20 Newton. Also the sliding distance has been varies from 1000 meter to 3000 meter of the component to get the proper idea. Also the temperature has been varied from 40 degree, 60 degree and 80-degree temperature to get the proper. Now, with this tensile, flexural, and the physical property investigation, that what are the component we can consider for this developed composite? Since plastic has to be removed or the synthetic fiber-based composite has to be removed, so on that basis what are the application can be applied with the result available. Most of the cases we can apply for the construction, it can be applied for the automobile applications, then furniture and some aerospace application where the reduced weights are there. So these are the application of waste derived from the composite material. Then these are the some specific application where it has to be applied the composite material. So if you can see that in a car dashboard we can use made from the natural fiber reinforced composite, and then in helmet also we can use, then the mobile shell, then roof. Okay, so these are the some application where I use now also the decorative item. We can use bamboo composite flooring can also used in practical application. Then the helmet, guitar, chair, solar panels are the application. So these are the some filler based product which we have developed in our laboratory: tray, pen stand, mementos for the application. Now another problem when we are considering, as I mentioned, that the natural filler based composite one mixed with the epoxy resin, whether it is a biodegradable or non-biodegradable epoxy resin, it lose the heat transfer coefficient, it lose the electrical property, magnetic particle property, and moisture absorption capacity, and some other poor resistance. But if we want to, so these are the some basic challenges. And even after investigating all the property, these challenges has been found, that is moisture is absorbed very highly, low durability, then poor resistance and complex recycling. So in that case what is the alternative? Since we have to reduce the uh, plastic item or synthetic item which are environment hazardous for the component, so in that case if we reduce the filler percent, we can make an hybrid composite. So hybrid composite means in that case some part are the though biofiller and the natural filler is the reinforcement material, and biopolymer matrix or resin are the uh, matrix material. Since we are not able to achieve some desirable property, so in that case some hybridization, that is synthetic item, has to be incorporated to reach the specific. Of course, a metal cannot be replaced by the composite material. Its strength, metal stainless steel strength cannot be replaced by the synthetic based composite or natural filler based composite. But if we can reduce the quantity, and most of the material can be replaced with the plastic or environment hazardous material with a composite material, that will be helpful to the environment. So in that case, hybrid composite is to be considered. So it has a very versatility, resilience and natural. So in that case, graphene nanoplate, which is a additional part of the uh, in addition to the jute filler and bamboo filler, some amount of graphene has to be incorporated as a reinforcement material to improve the strength, thermal behavior, electrical behavior, and the magnetic property of the material. So if it used, so in that case it has been observed that as the graphene filler incorporated, then the strength is increases a large, because if the filler without the composite is simple testing has to be done, then 10 kilonewton to 15 kilonewton has been found. Whether if it is considered incorporating graphene, that it becomes 21 to 35 kilonewton of the load has to be achieved, means almost uh, 20, 30 40 50% load has to be increased. So after incorporating graphene nanoplates with jute microfiller, this is the tensile strength. And if it has been observed that even with the graphene filler variation, the strength is increased up to certain level. Earlier we have varied the filler. Now specifically for jute filler, it has been observed that at 5% filler reinforcement, the material giving best tensile strength. So 5% filler has been considered for the jute. Now graphene has been incorporated, and the variation of the graphene has done, means point 0, point 2, point 4, point 6, point 8, and 1%, 1.2% increases. So it has been observed that most of the cases, point 2, point 4 to point 8% graphene incorporation increase the different property, that is tensile, flexural, tribological, corrosion behavior, all are increasing. And of course, after more than zero point 0.8 or 1 on 1 point graphene increment is to make the agglomeration or the debonding of the not make properly of the component. So here graphene with 5% filler, jute filler component is incorporated, and it has been observed that 0.4% graphene incorporation give the good tensile strength as well as flexural strength and the different property. And after that it start decreasing. Okay, so in that case also elastic modulus, ultimate tensile strength, flexural modulus and flexural strength, also bamboo with the bamboo also increases. In case of bamboo, it has been observed that 0.8% graphene incorporation is give the best property. Whether in case of jute, zero point 0.4 to 0.6% graphene incorporation give the best property, and in case of bamboo, it is giving at 0.8% graphene incorporation. But all the cases, it is to be assumed, remembered that in bamboo and jute, the filler incorporation is 5%. Okay. Same way, the uh, tribological behavior also investigated for both jute filler, graphene incorporated hybrid composite is investigated, and it has been found that with the increase of load, the wear is increasing, temperature is increasing, coefficient of friction is increasing for both with distance and other behavior. So that it is not that this is because of it is followed as similar to the uh, property investigated without the hybrid composite or normal composite material. But graphene improve the strength of the tribological behavior or removal of material also increase the strength and the property of the material. But another thing observe that since graphene is incorporated, in that case the corrosion is increases. So one side you get the good strength, tensile, flexural, ultimate strength, and tribological behavior, but thermal conductivity. But on the other side, since the uh, synthetic filler has been incorporated, the corrosion is increases with the time. Whereas in case of natural filler based composite, corrosion is almost nil. But in case of when the hybrid composite is incorporated, that corrosion behavior is increasing because of the presence of the graphene of the material. So these are the some advantages hybrid composite compared to the natural. It will give the good strength, lightweight, and of course 100% not eco-friendly, but certain amount of eco-friendly of the component. This can be used any car manufacturing, automobile interior, and vehicle performance of the material. Uh, and there are some futures provision is there which we are working that if the filler or fiber is instead of incorporating hybrid composite, some coating has to can be done, so that will be helpful or more, because when synthetic composite or synthetic filler has been incorporated, uh, it not then the aim of replacement of plastic is not achieving 100%. But if some coating is given to the fiber and the filler of the natural resources, it will give, if that coating is able to achieve the desirable strength, then also we can say that this natural resource based composite is good for the society and helpful and easily replaceable to the synthetic fiber based composite or the metal. So specifically, I would like to thank my student, this presentation preparation and all that thing, Ananya Kalita. She is my UG project student, and the good result is given from the Vijay Kumar Mahapur Research Scholar. And of course, I would like to thank the tribological. Most of the result has done Dr. Rajdeep Pal. So I have not written his name here officially, but yes, it is his result, his work he has done during the PhD work, and that has to be presented. Thank you for listening.
Thank you, sir, for this very much informative session. It will really helpful for all the audience who are present here. So now I would like to know from the audience, is there any question you want to ask? You can directly ask to the Bhumik sir. Any question regarding this lecture, you can directly ask to the Bhumik sir.
Yes, it is open to all. Anyone can make the question or future plan.
So I think there is no question from the audience. They have understood all the things. Or if anyone has any question regarding the lecture after the presentation, also we can share the email ID of the eminent speaker, so you can directly mail him. So thank you again, sir, for this informative session, and you have responded our call, and it will. We are very much glad that you have joined the session.
Okay.
So
Thank you.
Thank you for inviting me, and thank you Techno India College Agartala for inviting me. I hope it will be more interactive next time when we'll go physically meet, because online is okay, but sometimes it is very better. I can show the physical mode of experimentation and product development, so it will be more helpful. So one more
Yes,
information I want to share, that if people think that what we can do with this composite, it is not like that. We also make the composite for prosthetic limb also. Okay, so
yes,
using
yes.
lateral filler composite, and next plan is that when a hand is broken or leg is broken, some steel plate is inserted inside the broken part. So after 1 year, when the recovery was made, you have to make the surgery again, bring out the plates. So we have a plan to prepare such as biodegradable composite material. After 1 year, no more surgery is required. You can directly dissolve the material inside the body of the patients. So these are the also work. So don't think only we have made handstand and memento. Okay.
Yes, sir. It
Okay,
is very much. It will be helpful if the bioprosthetic legs, limbs, these things will made by these composite materials. It is very much helpful to the society also. So, thank you, sir, for joining with us.
okay. Thank you. Thank you very
Okay,
much.
sir. Okay, sir. So, I'm concluding this session.
Okay, I am leaving now.
Okay, sir. Okay, thank you.